Hi, everyone. I'm Laura Wilber. I'm an analyst at Enea AB, and I'm here today to talk to you about zero trust network access. Now, if you're involved in any sort of networking or security, I'm sure you've heard of zero trust, but you may not be sure exactly what it is. So I'm going to try to give you the basics in 5 minutes or less. So let's go. Now, first thing to remember is that ZTNA is not a technology. It is not a product. People shouldn't try to be selling you a ZTNA. It is a conceptual framework, a set of principles for protecting contemporary networks. It is also not new. A lot of buzz around it recently, but the roots stretch back to 2003 with a group called the Jericho Forum. And this was a group of Chief Information Security Officers, CISOs, who wanted to promote the deperimeterization of networks, and they elaborated the zero trust principles. And of course, networks without borders is what we have today. And for securing these networks without borders, there's sort of four key strategic functions within ZTNA, which we'll walk through. The first one has to do with authentication and authorization, identity, a rich multi-layered contextual identity-based access authorization and authentication. The second is that authentication is for authorization is for access to a specific application only, not to a network, just one application. And the trust that's placed in you to access that application is going to be continuously reevaluated. And if at any point it looks like trust is misplaced, your access rights are going to be changed or revoked. Now here, taking the airport as our example of a network, this is the first thing to keep in mind is this is a hostile network. In ZTNA, it is always assumed that there are internal and external threats present on your network. And here we come to the airport. We're going to catch a flight over here, Terminal 2F, Gate F35. But first, to gain access, to get authenticated, we're going to have to go through quite a gauntlet. There's going to be a multi-layered, if anybody that's traveled through an airport know there are a lot of stops of your identity, your credentials, luggage you're carrying is going to be inspected. Your person may be inspected quite closely as well. This is similar to the ZTNA complex authentication by identity. Now, if this was an old legacy network, we could go straight through to our gate here, F35, and wait for our plane, or, especially if we're a bad guy, we could go anywhere in our network we wanted. We could go grab a baguette, we could stop and get some caviar, we could go do some shopping at the fine discount stores here in Charles de Gaulle, take a swim in a connected hotel, go work in the business lounge and meet a friend, maybe take one of those USB keys, free ones, set out at the candy dish, hopefully not. But this is not a legacy network. This is a zero trust network. Now, the reason we could move around in a legacy network is everything is mapped and has an address, specifically an IP address. That's how internally and externally via the internet, we know how to connect to everything. But in zero trust, we just want to see the application we're going to connect to. So we're going to hide those IP addresses and with them, the assets that they're connected to. This helps enforce the access just to the application, not the network. This is all we can get to and see here, and we're going to get there via an encrypted tunnel. But as I mentioned, trust is going to be continuously evaluated, not just at entry. So along the way, traffic is going to be monitored and inspected to look for any sign of anomaly, any indication of bad behavior. Ooh. So we make it through that gauntlet and we are on our way to our gate. Once again, everything is hidden. We only see the access, we only see the application we're authorized to access. Here, it's our plane. And we're going to get there via that encrypted tunnel. But again, continuous trust evaluation, there's going to be another check at the egress, right? We're going to make sure that you are who you say you are. And once again, here's our passport, our ID. Maybe you even get inspected again on the way into the airplane. But we made it. We made it through the whole gauntlet and we are on the airplane. But we make a mistake. We try to sit in someone else's seat. So what happens? we have violated the trust. And your access rights have been revoked, and you are removed from the airplane. Boom. And that is ZTNA in a nutshell. Now, if you'd like to learn more, I invite you to visit the Enea.com website, where you'll find a lot of resources on ZTNA, and you'll also discover the role of Enea technology in building successful ZTNA solutions. Now, specifically, Enea offers two software libraries that are embedded by software vendors in their ZTNA solutions. The first is the Enea Cosmos IX engine, which is the market's leading deep packet inspection engine and provides all kinds of critical telemetry data that is used in all functions within ZTNA. And the other is the new Enea Cosmos Threat Detection SDK, which is a software library that combines the deep visibility of the Enea Cosmos IX engine together with core Suricata functions. And Suricata, which is the market's leading intrusion detection software, puts those two together, provides them in a form that can be embedded tightly within third-party applications so that vendors can easily build exactly the type of scalable, high-performance intrusion detection they need to deliver that continuous trust evaluation within ZTNA. And that is it for today. Thank you. I hope that helps, and bon voyage.